That might help.
So we didn't record any of that intro, and I'm a little disappointed in that. But the thing is, I don't think I could recreate that intro if I tried. So we'll just start from
Oh,
here, since anybody tuning into the replay hasn't missed anything but the intro. We are here to talk about Git, and so where do you want to start? Do you want to kind of give us a quick overview? And likewise, by the way, folks, everybody out there, thank you for joining us live on the webinar. And if you have questions, feel free to jump into the chat. I'm going to moderate some of those. Other than that, we're gonna kind of dive through for the next 45, 50 minutes and dive deep into all of this. Now, of course, uh, it goes without saying that we cannot do cover everything that we could potentially want to cover here in a day. So if you want to have the same experience that I had when I sat in on Raju's half-day Git workshop, what I would suggest to folks is that you dive over to No Fluff, Just Stuff. And this is, I know we've got some workshops scheduled. And in fact, just looking here, Raju, you personally have the Advanced Git workshop coming up January 13th. You've got a
yep.
Docker and Dockerfile workshop January 14th, and you're doing a DDD workshop on the 21st. And I've actually had the opportunity to sit into all of these, and they are wonderful. So, what No Fluff, of course, has been doing while we've been on hiatus in the in person events, what we've been doing is doing a lot of these workshops, live instructor led workshops virtually online. We're going to continue doing this because it has been a wildly successful format and it's very popular. So before we dive into the content, if you want to drop into this workshop and dive even deeper on any of these topics or anything that's on the No Fluff schedule, go to nofluffjuststuff.com and check that out. Of course, all of these workshops are a la carte, but if you want to continue this learning and kind of share this education resource with your team and your organization, then you can buy the team subscription and you get it's a per seat model, so one person for every seat that you have for any of these workshops, plus you have access to all of the replays at any time. And if you really want, if you're we're racing to the end of the year, and if you really want to burn up some of that training budget that's been in a wait and see holding pattern all year long, we have for a limited time only the No Fluff Just Stuff golden ticket. Until the end of the month, there are a handful of these left, and this is a once in a lifetime opportunity to get an insane price on the best educational content, live conferences over the next 5 years in the industry, hands down. So the golden ticket is one price, gets you access to one of our destination shows every year for the next 5 years: ArcConf, UberConf, Front End Fest, Progressive Web Experience, Tech Leaders Summit, any of these destination ML Fest, a Machine Learning Fest is another one that we do. So many of these destination events, you've got a ticket for the next 5 years. One of our tour shows, and we do these all over the country in the U.S. every year for the next 5 years, and you get that access to that the virtual workshop series, a live seat in all of those for the next 5 years as well. It's an incredible deal. It is strictly limited. There were only 200 when this was announced a few weeks ago, and I now we're down to just the last few. So if you've got that budget you want to when you want to use up, you want that resource to continue to grow as a professional for the next 5 years, do not pass this up. But anyway, enough about that. Let's actually dive into the content. In fact, I'm going to take myself off spotlight and I'm going to give you the floor. So, once again, everybody, thank you for taking the time to join us this morning. We're going to dive into Git, and if you want to dive deeper, I look forward to seeing you in the workshops. Over to you.
Oh, well, thank you, Michael. I was hoping someone would pose a question here about Git.
Well, I
Like
still
you
have
said,
questions.
well, I would love to answer them. And if you have any questions that you think will help the audience, then please fire away. Um, just a little bit of background. I think the first time I touched Git was in 2008. Um, and I was working with my colleague Joseph on a project, and I didn't know what I was doing. I was sort of suffering the Stockholm syndrome of using ClearCase at work, which is, I don't know if anyone's used ClearCase in this room, but
Is it better,
ClearCase,
worse, or the same than Visual Source Safe?
It's well, one's Microsoft, one's IBM. So take your pick.
Oh, everybody loses.
uh, yeah, so I see some people are coming out with the clear case hate, and what's funny about clear case is creating corrupted verbs. Oh my god. Um, Creating a branch literally meant an admin would have to come to like your laptop and like work on it to like create a branch for you. It was an astounding time. So when I got into this project, it was a website we were writing for some training thing that we were going to do, and um, he, my colleague Joseph, was working on a branch, and I did something, and then I read online, do a git push. I'm like, git push, and completely clobbered everything that he had done. So he spent like 4 hours after I had done my work to sort of fix all the issues that I had caused. And fast forward a couple of years later. So let's see, I just want to see clear case sort of a version control construction kit. Yeah, I can see that. But fast forward a few years later, and I am talking to Tim Berglund, who was a speaker on the No Fluff circuit, was talking about Git, and Matthew McCullough was spending a lot of time with Git, and they did an O'Reilly sort of video recorded session with Git, and I was already sort of knee deep into Git, and I watched that, and I understood the directed acyclic graph and the data structure that Git uses, and off to the races. And now I think it's one of the coolest piece of technologies out there. I really do think that, I said this a while back. I think I said it in 2014 or 2015, and I'll say it again, that in my opinion, if you're looking at contributions, right? Linus Torvalds created Git, and he also created Linux. And obviously a lot of people know him because of Linux. In fact, he's pretty much hands off Git, right? He doesn't manage the Git project at all. But he did create the first iteration of Git. And I think that from a contribution perspective, I think that his biggest contribution to the world is or will be Git in the long run, and not Linux. And recently I read an article where I think Linus himself admitted to that himself, because he felt that the impact Git is having on the world is bigger than the one Linux has had. And that's partly because, GitHub and GitLab and Bitbucket and all these sort of vendors making this huge impact on the ecosystem and sucking in more and more mind share. But I also think that it's because teams have realized that it really works for most use cases, right? I know I can think of a handful of use cases. Actually, one that our friend Venkat has that Git does not work for, right? But generally, it works for most use cases. Oh great, I got a question from Srini. Any suggestions on how to remove a bunch of?
We got a whole stack of
What was that?
questions.
Oh,
So
nice. Okay.
So do you want to just start going through?
Why don't we just let's knock them out. Let's do what the people want.
All right, I like this. I like this.
I love it.
So so just kind of starting from the beginning, we got a comment here, or starting from the end, I guess. We're going last in, first out. Git is a distributed system. Most older version controls are not. That is a true statement. And when you were talking about 2008, when Git was my first interaction with Git was around 2009, and so I wasn't too far after you, but I don't know. I was observing a shift in complexity, and I don't think it was actually a shift in complexity. It was that I was outgrowing the sort of simplistic client server software development that I was doing in the early aughts. And one of the observations that I had was that it just seemed like there was a trend in technology to do things the hard way because it was cool. And my perception of Git was that this is just somebody's just trying to make version control as hard as it could possibly be. I'm used to using Subversion. We had Turtle SVN, which is integrated into our IDE, and we had these little GUIs and things like this. And this wasn't hard. And all of a sudden, I've got to go in the command line. What is this? Like, why am I doing? What year is this?
Yeah,
We
what
have
year
all
is this
these nice
exactly, right?
tools and abstractions, and it took me years to figure out that, oh, there's a lot of power here, and I still like visual diffs. I don't like doing diffs on the command line. There are tools that visualize this so much better, but it took me a little while to understand that. Yeah, a great point, Jonathan. When Git came out, it was solving problems that not everyone realized existed. That is maybe one of the truest statements that I've heard in a very long time. That it is exactly that. It is that um, we hadn't met that, because I'm running into this right now in my day job. Is that I'm looking at technologies that most people don't look at because they haven't run into those problems yet. But let's
Actually, I
kind of
don't know if I agree with that statement, because
really okay.
Git came out as a response to Perforce licensing, right? So Perforce did what Linus wanted it to do, but then they had this licensing issue, and then he got pissed at them and decided to write his own version control system.
I'm still on
Um,
camera.
that's okay. It's lunchtime. Um, so somebody said this. Jonathan said, when Linus scratches an itch, you pay attention, and that's a point I think accurately put by Jonathan, which
Okay.
is yes, the problem was somewhat being solved, but not solved in the way that he thought scaled in the way he wanted it to scale. Um, but anyways, so yes, but I think that Git solved a problem that Git was ahead of its time, right? The distributed version control system, the fact that you can go offline, a lot of these things are beneficial in a world where we are constantly going. I mean, I know old people like you and me, Michael, talk about getting on the internet, right? Kids,
There's
kids these days, like they're
there are entire generations that were born already connected. We had to
yeah.
dial up
So
over the phone. Kids, I kid you not. In our day, we used to download Netflix through the mail.
yeah, it's true. But anyways, so okay. Um, somebody said we had UCP. Okay, so somebody asked, let's see, Git is a version control system. Or somebody had the obligatory XKCD comic, which I think is the one that is just nuke everything and clone again. I think that's
Yep.
the one, right?
Yeah, I
1997.
can. Yeah, I can. Let me. Yeah, that's the one that was
Yeah.
on in the tweet.
So why Git versus Subversion versus Perforce versus some other version control system? Oh, that's a great question. You got any thoughts on that, Michael?
Well, I've never used Perforce, and I've used Subversion and Visual Source Safe and Source Vault and Git and Mercurial, but I can't comment beyond that.
I
But
think that Git has a couple of things going for it today, right? So 10 years ago, maybe this was a different conversation, but a couple of things Git's got going for it today. One, like somebody mentioned, it's a distributed version control system. And the fact that doing anything in Git doesn't affect, quote unquote, the master copy has huge implications, right? The ability for me to experiment and iterate and check the logs and diff and do whatever I want to do, knowing that I am safe away from everything else, has a big proposition value. I think that Git's fundamental data structure that it uses is simple once you wrap your head around it. It's not easy, right? It's a hard data structure to get your head wrapped around. But once you understand it, things are a lot more logical than other version control systems, right? So it requires, to Michael's point, the command line, right? Which is sort of both the Achilles heel and the strength of Git, which is they expose this extremely crude interface to you that is overwhelming to a lot of newbies. But the biggest thing I think going for Git today is mindshare. The number of
Mhm.
tutorials, the number of blog posts, Stack Overflow questions, the number of resources, whether that's Bitbucket or GitLab or GitHub, third-party hosted solutions, and all of the tooling that's being built on top of Git, right? So now today, Netlify connects to GitHub, so you push a commit and your website gets published automatically. So it's sort of like buying into the Kubernetes bandwagon, right? People don't buy into Kubernetes because it's simple. It's extremely complicated infrastructure, but what you're buying into is a mind share. All the tooling, all the third-party add-ons, all of the help, all the documentation comes with it. Somebody is a Maggot fan. Ooh, Maggot, Emacs for the win. And then very quickly, let me answer. Oh, sorry. I just want to answer Srini's question because before it scrolls off the screen, I just want to be sure I cover it.
For sure.
Any suggestions on how to remove a bunch of files inadvertently committed to a merge request only realize after the fact? I was embarrassed to do this, but this works. Backs up my stuff, blow away the folder, clone it afresh, and copy the stuff I want with this. Yes. So what you're looking for, Srini, is something called Git Rebase Interactive. And what you can do with Git Rebase Interactive is you can replay a bunch of commits. So let's say you have 5 commits in your branch. You can replay each commit, pause at each commit, and then do whatever you want to each commit. So you're effectively changing a commit after it was committed, right? It's not trivial to do a Git interactive rebase, but the problem you are trying to solve is essentially, that's what Git Rebase Interactive was designed for, is the ability to edit a commit after you had made it. Now, I will mention this, two things I'll mention. One, like I said, it's not a trivial exercise because you really need to understand how Git works, right? So it's interactive rebase. I know Michael and I sort of gone back and forth over this a few times. The second thing I'll mention is that if you inadvertently committed sensitive stuff and you pushed upstream, right? So you push to GitHub or GitLab or whatever.
I've done that.
I would just assume it to be compromised. Just rotate everything. Even if you remove the files, doesn't matter. Just automatically assume you're compromised, rotate everything, and then move on with your life. Because there are actually people sniffing out traffic towards GitHub for keywords like password or whatever. So
and regex is for tokens and keys as well.
Yep,
in fact,
and they're sniffing out the traffic. So
yeah, I think in 12 hours, there was a guy who had a 5-figure AWS bill that was accrued in just 12 hours, even after going through and rotating things. But it is cool that you can commit something that you don't want to commit, push it to origin, and if you understand how Git works under the hood, you can fix that. That you can go back in time and resolve that issue. And thanks to what I learned from you, I've done that. It was in a private repo, and it wasn't something quite as bad as my AWS keys.
And then Bruce has a similar question. He said, problems rebasing a master branch with a remote master repository, got innumerable needs to git merge, continue, eventually gave up and git reset hard. So is there a way to just say, make my master branch match the origin master without blowing away by commit history? So I believe what Bruce was trying to do, well, so the question is a little confusing. If you're rebasing a master branch, so why didn't you just try doing this? So let me just type this here. So at Bruce. Oh, that doesn't work, does it? No, I'll just type at Bruce. It doesn't work. At Bruce, git reset hard. Why not just do that? If you're trying to catch up with master, origin master, or upstream master, whatever your upstream is called, you could just make sure you are pull down the origin master and then force your master branch to reset to that thing, and it will bring it back at parity. There's no reason you should not have rebase to begin with if all you were trying to do was catch up, right? Because what you are saying essentially is what you're trying to say is my master is different than upstream master, and I want to bring my changes on top of what someone has put on origin, right? And that's what you're saying when you're rebasing. When you're rebasing, the analogy I like to give is you are relocating your commits on top of something else. If all you want to do is catch up, just do a git reset, and and you will come to that parity. It doesn't have to be origin, right? It could be any other branch.
Would it be worth,
So then,
Raju, at this point, to go through and just kind of talk very briefly about the underlying data structure and kind of how visualize this? Because I know you've got some
yeah,
illustrations. Would that be useful?
sure. Let me do that real quick. So let me see if I can start a screen share here. For
All
a
right.
person who supposedly knows technology, I am terrible at this stuff.
And
So let
then
me
I'm going
just
to
open
collect a
up
few questions here while you're doing that.
Sure. I have the slides open here. I'm just trying to get to the right one so that we are on the same page. Give me 1 second while I find it. Okay, so that should be a good one. Let me do a share and we'll see how we do. So Michael's collecting questions. For those who are listening in, fundamentally, here's that data structure you need to understand, right? Fundamentally, what you are trying to do is you're trying to build essentially what is called a directed acyclic graph of commits, right? You can, for the most part, this piece on the right-hand side is something you can choose to believe doesn't exist unless you're really trying to understand how Git works. So let me explain what the right-hand side is. In Git, right, your files, like when we add a file, right, Git add file name, right, you're not actually adding files to Git, right? You never add a file to Git. Git does not track files. Git tracks the content in files. And that's an important distinction. In other words, if I have a file called hello world.java, Git doesn't care it's called hello world.java. Git cares about what's inside that file. And it stores that content in something called a blob, right? A blob is basically an object, a Git object that stores the content of files. So for every file that you add into a Git repository, Git will create a corresponding blob for that file. Every time you edit that file, Git will create a new blob to represent the contents of that modified file, right? Now, of course, at some point you have to recognize that there are names of files and types of files, right? So what's the name of a file? Hello world.java. What's the type of a file? It's a plain text file. Somewhere that has to be recorded. And so what Git does is it stores all of that metadata about what file and where it is in your working directory in something called a tree, right? So a tree represents the structure of your working directory, insofar as all the files that you've added to Git are included. So a tree represents one directory level in your working directory. So your root level, let's say, has one file and one subdirectory. That is a tree with one blob. Remember, files are stored in blobs, and a subtree, because directories are represented as trees. So if you look at this top level tree on the screen right now, this is the top level tree. What it's saying is that, oops, I'm sorry, this tree constitutes itself of one file, right? That's a blob. And then that tree has a subdirectory. This is a nested tree, which has one file in it. So looking at this data structure, I can tell you what your working directory looks like. This information is stored inside a commit. So every commit has a reference to the tree object. The tree object shows Git what the working directory looked like when you made that commit. Now, regardless of whether this is something that you care a lot about, the most important thing you have to understand is that Git fundamentally is made up of two separate data structures, right? The first one is called a Merkle tree. This is very popular in blockchain or IPFS. Basically, a Merkle tree is where the identifier of any object, remember that your Git commits have an ID, right? Every Git commit has a unique ID. That Git commit ID is calculated by all of the contents of that commit, right? So that's a Merkle tree. And then the other thing you have to understand is that all the commits are forming a directed acyclic graph, a DAG. And so fundamentally, the data structure that Git is using under the covers is something referred to as a Merkle DAG, or a Merkle directed acyclic graph. So a directed acyclic graph made up of Merkle trees. Once you understand this piece, and I know I sort of flew right all over glossed over all of the details, is the trick to understanding Git, right? This is how you get some of the questions that we have about rebase or reset. Some people said, you know what, I figured it out. I tried a rebase, it didn't work, so I did a Git reset. What does that mean? What is the difference between a reset and a revert? It all has to do with the directed acyclic graph. What's the difference between a merge and a rebase? It all has to do with directed acyclic graph. What is a branch? What is a tag? How does head work? What is detached head state? Everything has to do with this directed acyclic graph. So what I try and teach when I'm teaching Git is how to visualize how this graph is being constructed as you make commits, right? As you're working in a repository and you create branches and you make commits on every branch, or you have a remote upstream and a local clone, you are making commits, colleagues are making commits, you are pushing upstream, they are pulling stuff down. What you are sharing between all of you is this graph, is this directed acyclic graph. That's that, and maybe a handful of other things like tags get shared, right? Um, but the point to take away from all this is the key to that place you might have found yourself where I don't know what to do. I'm just going to blow away everything and clone the repository again. That very rarely happens once you get past understanding this data structure, right? Um, how is that, Michael?
Oh, that sounds great. Here, come back on camera here for just a quick moment, because I think this is
Oh yeah.
a good transition point to. I'm trying to get a little more structure into what we're doing here, and how we're approaching this, just for folks who are
I am not
listening or
helping, am
watching the
I?
replay. That works out. So I'm gonna pop back down here, and I'm gonna start with this. So, because you're talking about those data structures, and for me, when I sat in your workshop and you started to lay this all out, it was just like, oh. And suddenly I looked at the command line tools, and I was just like, oh, this, I need to do X. Oh, there's a tool for this. I need to do Y. Oh, there's a tool for this. Oh, there's a command for this. And suddenly, I wasn't overwhelmed with complexity. I felt like a god of. I felt like Neo, and my source code was the Matrix, and suddenly I could make bullets stop. And it's a wonderful aha moment. And that actually brings us up to one of the first questions that I have here from Walt. And Walt asks, what was your aha moment for you, Raju? And I don't know why there's I don't know what this is, so I'll just take that off. What was your aha moment that finally made you get Git, as it were?
It was this understanding this data structure. In fact, my first time around, I didn't even know about trees and blobs and all that business. All I understood was every time I make a commit, I'm adding to this graph. Every commit I make knows its parent, right? So it's a
Mhm.
directed acyclic graph because children know parents, parents don't know children. That's why it's acyclic. Once I understood this idea that you have a directed acyclic graph under the covers, and this is the big thing you have to understand, commits are immutable. Once you make a commit that gets a unique identifier, you can change a commit after you made the commit, but you get a new identifier. Git never reuses a commit identifier because, again, it all has to do with the Merkle tree. The contents of the commit dictate the ID of the commit. So if you change, say, a file and you amend a commit, you are affecting the ID of the commit. That's the power of the Merkle tree, is that
Mhm.
integrity is maintained at each commit level, and uh, that it forms a graph. These are the two things that you need to understand.
And although a commit is immutable just by its very nature, they still can go away. Do you want to talk a little bit about garbage collection, and how you can abandon a node on that graph?
Oh yeah, that's a great question. just real quick. So Jonathan asked, the diag is a tree structure in which each. Okay, we'll come to that question in a second. Let me just share my screen here, and then we can talk about. That's a great question. So let me just let's just take this example. So did that work? Can you
Yep.
see my screen?
You look
All
good.
right. So let's take a look at this directed acyclic graph, right? So what happened here, again, I've spent so much time with Git, I can read a graph and sort of know the history, right? So here what happened is there was an initial commit on the master branch. And then somebody made a second commit. So master branch now points up here. But then somebody created a branch called new feature over here, switched over to it, right? So they moved from master to new branch, and then they made a commit on that branch, right? So that's your history right there. Now, if you've done Java or Ruby or Python or whatever, and you've ever had a variable point to a hash map or a tree map or an array list or whatever, some data structure, and then you set that variable to null, what happens to that graph? What happens to that object? It eventually gets garbage collected in garbage collected languages like Go or Java or Ruby or whatever. Well, here, because this is a graph, this graph will be retained as long as every commit in this graph has something pointing to it. So the first question is, why will A always be around? Well, A will always be around because B is pointing to it. Why will B always be around? Because C is pointing to it. And why is C always being around? Because new feature, the branch refers to that commit, right? So as long as you have a reference, like a branch or a tag to a commit, the commit will stay in your history. Now, what happens if you delete this branch? Let's pretend you deleted this branch, right? What happens? Well, let's look at the data structure after that. Nobody is pointing to C. C is pointing to B, but B is being pointed by master. So what will happen is eventually Git will run a garbage collection cycle, and it will find every object that nobody cares about. So this is a commit left behind, right? This branch is no longer there. Nobody is pointing to C. C gets garbage collected. But why doesn't B go away? Well, B has a reference. Master branch is pointing to this commit. So B will stay as long as the master branch exists. And A will stay because B is pointing to A. Remember, every child commit points to its parent, right? So if you make a commit and then you make a second commit, the graph is constituent of two commits, right? B and A. So this is the garbage collection cycle in Git, right? And inadvertently, what you might do is forget that, when you delete a branch in Git, Git won't let you delete a branch that's not merged, right? Why is that? Because of this reason. Git will say, if you want to delete a branch that is not merged, you have to give it the uppercase delete flag. So D for delete, not lowercase, uppercase. Why? Because it's saying make an explicit choice here. When you delete this branch that has not been merged, you will lose this commit. So you need to explicitly buy into that choice. Now, very quickly, what happens when you merge, right? That's a sort of important question. So let me just move over to merge. Okay. Okay. So when you merge two branches, right? I merge master and I merge another branch together, what happens is the child commit actually has pointers to both the parents. So there are two commits that are coming together to form a child commit. The child commit points to both. So now, even if I delete this branch, which is typically what you tend to do, right? In GitHub, you say delete this branch after it's merged. This commit isn't going anywhere because the child commit points to both parents. As long as somebody's holding on to him, like this master branch here, this graph stays, which means everything underneath it stays. Does that make sense, Michael, or did I go too quickly?
It makes sense to me, but I got the full treatment earlier, so I would invite folks to weigh in on chat. But
Yeah.
but actually, while we're here, while you've got this graph up and this slide up, one of the questions that came in from Josh was, what's the difference between a branch and a tag?
Ooh, great question. Great question. So the way I look at it, right? is that a branch, let me just show you this slide in its entirety, right? Actually, you know what? Let me just go to my branches exercise. That might be easier. By the way, somebody asked how I made these diagrams painfully by hand. So don't don't be too impressed. I didn't have any fancy tools to make this. Okay, so let's talk about branches. A branch is basically a post-it note, right? It is literally that, right? A post-it note. And what does the post-it note have on it? It has the name of the branch. In this case, on your screen, you are seeing I have two post-it notes in my repository, master and new feature. Alongside, so Git now has, right, sort of two post-it notes, right, in my repository. What it does is on this post-it note, it writes the ID of the commit that it's pointing to, right? So in this case, let's say the ID of my commit is B. Master and new feature are both pointing to B. They have the letter B written on them. Now, let's say that you make a commit on a branch. Let's say you're on the master branch and you make a commit. What happens? Well, the new commit will show up, right, in the directed acyclic graph. And then what Git does is it takes that post-it note and it scribbles out B and puts the letter C. So now what you have under the covers is that you have a post-it note that has overridden its previous commit ID and is now pointing to the new commit ID. That's it. It is literally a post-it note. When you delete a branch, all Git is doing is it's taking that post-it note and tossing it away. In other words, it just deletes this post-it note. That is all that is happening. Nothing else happens when you delete a branch. When you create a branch, all Git does is it creates a branch with the name you gave it and says, oh, you want the branch to point to this commit? I'm going to put the letter B in that post-it note. That's a branch. A branch tracks every commit on it. So every time you commit on a branch, that post-it note gets rewritten with the new commit identifier. That's why the branch moves as you are committing. Every time you commit on a branch, the branch moves. A tag is a post-it note, except the identifier of the commit is written with a Sharpie. You can't erase it. You can't rewrite it. In other words, when I create a tag, and let me just show you here. Here. So a tag points to a particular commit and it never moves. In other words, if I were to tag this commit, Git will create another post-it note called v1.o.o, write the identifier in it with the letter B in with a Sharpie. Now, even if you commit on master branch, like for example, if I commit on this branch, I get a new commit on master branch. Master branch moves up, but the tag stays exactly where it is, right? So tags don't move. Branches track every commit on that branch. Does that make sense?
Yeah, and actually
Hopefully that
another way
helped
to
the question.
another way that it's put here from Jonathan says branches are pointers and as such are mutable.
Mhm.
By the way, you can see the fundamental differences between Raju and myself illustrated in how we deal with post-it notes. I noticed, Raju, that you, although you've crumpled up the post-it note, you very carefully placed it into the wastebasket where I would have just thrown it over my shoulder. And that is the difference between the two of us, by the way.
All right, what's next?
All
Who's
right.
next?
So the next one, this came up, and I think this is addressed, but I didn't mean to do that. There we go. I wanted to do that. This came up, so let's go ahead and throw this in here. Just a quick Git versus. Can you elevator pitch why we would use one versus the other? Because
Yeah, so we talked about this. Yeah, I think that the biggest selling point right now is the mind share and everything that's been built out of Git. In fact, you can actually expect an explosion of tools that are going to be built on Git because of Microsoft's acquisition of GitHub, because they are going to suck it into Azure DevOps, right? So GitOps is becoming a thing now because of this acquisition. Like Microsoft has finally said, we have a powerful tool that we can build off of an entire ecosystem of tools, and then every other vendor is going to play catch up, right? So this is happening. If nothing else tells you the fact that Microsoft believes that the future of the cloud, right, and GitOps or operations, right, is in
Mm.
Git because of a $7 billion acquisition or whatever the hell they put in that money, is that should be a selling point to me. That's huge.
And I think there's we got to address that as well because there's a lot of OG Microsoft opinions floating around. Because fundamentally for me, I believe there are two Microsofts. There was the Microsoft that was Bill Gates, yep, Steve Ballmer, Paul Allen, those folks. They're all gone, and now we've got Satya Nadella, and everything is going in the direction of open source in Azure. Azure, according to Cloud Wars, Azure is now the #1 cloud vendor in the world, and they're really changing a lot of things. So where I work, it's a .NET shop for better or for worse. I like the language C#. I dislike the ecosystem for trying to build modern applications. And we had this debate. It was like, well, why is everything so much better in Java when Java's kind of clunky in places? And I thought about this. I realized it's because if you want to build anything at scale, you weren't going to spend $1 billion on Windows licenses. And just Google wasn't going to do that. Amazon wasn't going to do that. Nobody was going to do that. They built everything on Java and Linux and all of this open source ecosystem. As a result, the tooling and the ecosystem around that flourished. Now, Microsoft is
Right.
trying to catch up. And I think they're doing a great job, but it's going to take a couple of years. I just, again, looking at this, it's like looking at anything of any meaningful scale. We were looking at Hazelcast. They got a wonderful Java client, and they've got a pretty awful C#, and that's the story. But your point that your point, Raju, that GitOps is the future. This segues really nicely into another question that I had just prepared, which is this: Git Flow versus continuous delivery. If you listen to Jez Humble and a lot of those folks, that if you aren't committing to your trunk every day, and that commit isn't, and everybody in your team doing that, and all of these rules, you're not doing continuous delivery. And so it seems like Git Flow and the Git ops and stuff like that are seemingly at odds with these practices of continuous delivery. Can you kind of talk about the differences? And as somebody who's spent a lot of time in the DevOps space, uh, your thoughts on all of this?
I think it's a maturity model. It's kind of like saying, should you write a monolith or should you do microservices? And it all has to do with your engineering practices. How comfortable are you with the design architectural choices that come with that, right? So let me, thank you, Joshua. Yes, the answer, it depends. But let me just share this with you, right? So just to give you a sense of Git flow, so I have a diagram here. By the way, somebody earlier asked, can a tag be deleted? Yes, a tag can be deleted. You have to force tag delete. But again, if you have pushed a tag upstream, it's a little tricky to delete tags, right? So let me just quickly show you this diagram. And I know I'm not screening just yet, so give me 1 second. Okay, so, all right. So this is the diagram for Git flow, right? And I mean, if you break it apart, it's actually a reasonable model for teams that do branch-based releases, right? Where you don't have the level of expertise that comes, sorry, not only the expertise, but also the tooling and experience that comes with master is always deployable, right? What does it mean to be able to always deploy a branch on every commit? Well, you need to know the commit works, which means unit testing, integration testing, smoke testing. You need CI/CD pipelines that can automatically take that commit and promote it, right? To dev, to QA or ULT, to production. You need appropriate checks, whether that is compliance, whether that is quality gates, whether that is approval processes. The point is, continuous delivery, again, continuous delivery, continuous deployment, that it all depends on how you phrase that, or trunk-based development. The idea is that you need a high level of engineering maturity to get to that point. The nice thing about Git Flow is that you create a release branch, right? And that branch can be deployed to QA, and then people can test it and smoke test it. And if they feel they are ready, they take that branch and go to production with it. But master or developer or whatever your branch is for day-to-day work can continue to progress without affecting what's in the release branch. This is that separation of concerns, right? But the problem with that is it's slower, right? There's a whole release engineering process. People get together in rooms, and Confluence pages are created, and people are doing the Kumbaya dance, whatever. The point is that slowing down of the process is somewhat reflective of the engineering practices that have happened in your software development cycle. So yes, trunk-based or continuous delivery is at very odds with Git Flow, which is a branch-based release engineering exercise. But it's not a question of one or the other. I work with clients all the time, and I'm usually trying to get them to say, how close can we get to trunk-based development without breaking the world? But that always means I need to revisit their architecture, their design, their testing, their coverage. What quality checks do they have? Build their CI/CD pipelines for them. Ensure compliance. A lot of my clients have PII or PCI compliance, where the person writing the code cannot deploy to production. How do you put those checks in place? So the point is, one isn't better than the other, but one is more mature than the other, and but is at a much higher cost, right? A lot of times, and again, in the world that I know Michael's org, at least from what he has expressed to me, seemingly is going down this road. I have worked with clients that are going down this road, that you eventually reach a point where you're just testing everything in production. And what that means isn't testing with your clients as scapegoats, but the final testing has to happen only in production, because the scale at which production is set up, nothing else can be set up. It's too expensive. But this is the fundamental sort of dichotomy you're playing with, right? It's not one or the other's better. Is you have to people always ask the wrong question. The question isn't, shouldn't we be doing Git Flow or continuous delivery models? The question you should be asking is, how mature are our engineering practices when it comes to software development? If you don't have, if your solution to QA is to throw more bodies at the problem, you are not ready for continuous delivery, right? That's not going to happen.
We got a question came in here. Has Git bisect been a lifesaver for anyone? Yes. I don't think enough people know about Git bisect. Something broke. I don't know what. It was working here. It's not working now. Something here happened. There's 25 of us. What was it? So one of the questions that came up, by the way, that I want to throw in here, because we're getting really tight on time, we're racing to the end of the webinar here, is this, and I know nobody can see this. Please explain a rebase versus a merge. There's some interest in that in the
great
chat.
Question. All right, so very quickly, and this is a long topic, but I'll explain what. Okay, so I talked about merge earlier, right? So if I have two branches, right, I have a branch here and I have a branch here. When I merge the two together, what I get is this child commit, which is the child of two commits as individual parents. So whenever you do a merge, I like to call it marrying. Like M is for merge, M is for marriage. Two commits get together to form a child commit, right? That's not always what happens, but typically that's what you're doing, is you are creating this weird triangle that you see right here, right? Now, what is a rebase? If I take a situation like this, right? So I have this branch and I have this branch that has two commits. When you do a rebase, what you are saying is, I want to relocate this branch on top of this branch. Basically, you want these two commits to be on top of this. Notice that right now, this commit is on top of this commit, like it's built off of that commit. But what you are asking in rebase is, hey, Git, pretend that I started working on A after this commit happened instead of after this commit happened. So what Git does basically is it actually does something like this. When you say Git, take this branch and rebase it on some other branch, like rebase on top of master, Git actually first strips away all the branch information. It actually breaks apart each commit in that branch, right? So it takes the bottommost commit and then tries to merge it with master's changes, right? So basically changes that commit to accommodate all the changes in the new commit you're rebasing on top of. So A is now A delta. It changed because it is now including or is inclusive of all of these changes as well. Earlier, it only had these changes. Now it has these changes as well. Then, because A is rewritten, they apply B on top of A, right? And then Git brings back all the branch information. Oops, I'm sorry. So the difference between a merge is that in a merge, you typically get this weird triangle, right? This weird triangle. But in the case of a merge, you see how the history looks. It's one straight line, right? Linear history all the way. So if you want clean history, right, Rebase takes more experience, but what you are getting is that when you look at your Git graph, you see one straight line. You don't see all those weird triangles show up everywhere. That's the benefit of Rebase over merge. The downside is Rebase is a little bit more arduous to work with than merges. So again, glossing over a whole set of details here, but hopefully that sort of helps you at least ascertain or understand if one over the other.
All right, and we are rapidly running out of time. A few more things in the chat. Somebody said Git blame is of critical importance, and of course, I had to link to Git blame someone else, which is also should not be overlooked as a useful tool. Some questions on the replay. The replay will be available at nofluffjuststuff.com. And in fact, if you are on a normal size, non-mobile, non-tablet display, you'll see 3 columns on the NoFluff website. The right-hand column is our upcoming, current, and previous webinars. And you can access those there and follow that into the entire history. We've been doing these basically weekly all of this year, and we've got almost 30 or 40 webinars recorded, and this one will be included. And let's see, looking through the comment here for one of the earlier questions. Subversion does not allow you to do offline commits. I think that's really key. And for me, actually, there's a clear difference between checkpointing your work in progress versus versus going into one commit when everything is done. I love having those checkpoints, and I would never ever go back to not doing that. Although that brings up another question: do you squash before you commit? There's so much more in this topic, and regrettably, this is not something where we are out of time. I'm going to cut over to this, and I'm going to see if I can. Let's see if I can. I can. All right. I don't. Go ahead and come off the screen share for just a moment,
Oh, I'm sorry.
Raju.
Am I still on screen
Oh no.
share? I apologize.
Oh no, you're good. But yeah, check this out, nofluffjuststuff.com. Spend half a day, hands-on, really dive deep into all this and cover everything. Also in a more structured format than these kind of Q&A based webinars allow. And also, if you want to learn more than one thing over the next 5 years, it is definitely worth checking out the No Fluff Just Stuff Golden Ticket Sale. Once again, this is an incredible opportunity, and I truly believe, having been involved with No Fluff Just Stuff now for 10 years, I truly believe this is a once in a lifetime offer. So definitely definitely do that. And some more comments here. By the way, I'm just going to jump back to me. Let's see if I do this, it's not gonna irritate me with my little label popping up again, which is good. And I'm gonna add you in here as well. So a couple other things in here. Why do you use Git blame? If you can say a few words. We are out of time, unfortunately. I do like Git enables you to run the project your way. Of course, Raju is one of the most generous folks I know. If you want to continue to ask questions, at loosely typed on Twitter. And And actually, I'm just going to put his cell number in the chat here as well. Just shoot him a text anytime, day or night. I won't do that, but Twitter is a good way to interact. But I think that's
Joshua beat me to it, but thanks, Joshua.
awesome. Thank you.
I'm just going to say this real quickly. A lot of people ask, the question that they asked, Subversion versus Git. I think the word commit in Git is a terrible name, because the nicest thing about Git is when I make a commit, I'm not actually committing to anything till I push upstream.
I like that.
That's a huge plus for me in Git. It's nothing goes upstream till I explicitly tell it to go upstream. And
So
that's when I'm committing to my work.
Maybe Git checkpoint is a Git commit, and Git commit is a Git push.
Yep, that's the way it should have been. Yep.
Yeah. Well, it's one of the two hard problems of computer science: cache invalidation and naming things and off by one errors. That joke never gets old because it was never not old to begin with. Old is relative. All right, folks. Thank you so much for taking the time to join us here on this Friday. I'm pretty sure we are off next week for the holidays, but once again, very grateful to see everybody. Raju, thank you for your expertise and insights as always. And for everybody out there, stay warm, stay safe, stay healthy, stay sane. Look forward to seeing you on the road somewhere in 2021.
Happy holidays, everyone. Bye-bye.
Happy holidays.
Thanks, everyone.